2020 question 7. We're given this diagram of a cone, and it's a biodegradable paper cup in the shape of a right circular cone. Radius 3.3, slant height 9. Show that the vertical height of the cup is 8.37. This height here. So we just got a right angle triangle here. So it's just Pythagoras for part A. So we've got a right angle triangle with a diagonal of 9. So x is equal to the square root of 9 squared minus 3.3 squared, which is equal to 8.37. So nice easy start to this question. The curved surface area, well, curved surface area, we just go to the tables, curved surface area, and we get the formula, which is pi or L, and we just fill these values in. Pi by the radius 3.3 by the slant height of 9 is going to give me 93.2.31 centimeters squared. Now we've got the net of the cup, and we've got the area of the net. We've just gotten the area of the net, and the area of a sector. Area of a sector is pi or squared as the whole circle, so multiplied by the size of the angle divided by 360 will give us the area of the sector. So that whole thing is equal to 93.31. So we can just multiply across here. We've got pi by 3.3, sorry, by 9 squared. Apologies, pi by 9 squared by theta is equal to 360 by 93.31. So dividing across by 81 pi, I'm going to get theta is equal to 360 by 93.31 divided by 81 pi, and that's going to give theta to be 131.98 degrees, 131.98. I've used 3.142, and then I used pi, I got 132.002, so they're both the same distance away from to the nearest degree, 132 degrees I'll round it to. Part B, in order to avoid spillages, the cup is marked with a dotted line at F, so it's just filled up to here. They don't fill it up all the way, so they fill it up to here. So what do we need here? We need the radius of this new fillage, and similar triangles always come into these questions with cones. So I have two similar triangles, should help me find the radius. The big one, 3.3 over 8.37 is the big triangle, and the smaller one that we're now dealing with, we have a radius, and we have this 7.37 we're told is the height of it. They've moved down a centimeter. So we can get R here. 3.3 over R is equal to 8.37 over 7.37. So 3.3 by 7.37 is equal to R times 8.37. So divide by that 8.37. And that's going to give me R to be, what am I asked for the answer? No, I'm asked for the end answer, 1 decimal, so I won't round off too early. 2.9057. I'll leave it at 2.9057 for now. So we're asked to find the volume of water. So we're going back to our volume formula now. So the volume of water, volume is equal to 1/3 pi R squared H. So we've got a third times pi times 2.9057 to be squared times the height, which is 7.37, and that is going to give an answer of just over 60. 1 decimal place, 65.16. I'm getting with 3.142 and just over 2, so 65.2. They always, whether you use pi in your calculator or 3.142, which I kind of have a tendency just to type it in, you'll get the same answer regardless of which one you use when you're rounding. Water flows into one of these cups through a cylindrical pipe. Tiny diagram here, I can't put the radius on it, but here's my pipe, and it flows at a rate of 2.5 centimeters per second. So if I have a cylinder flowing into a tank and its length is 2.5 centimeters, whatever's in a cylinder of length 2.5, so the height of the cylinder 2.5, if I turn it around this way, and a radius of 0.8, in 1 second we get the volume that goes into the tank. So the volume of a cylinder is pi r squared h. So what's going in 1 second is pi by 0.8 squared by 2.5, and that's giving me 5.0265 centimeters cubed. So that's what's going in 1 second. Its overall volume is 65.2, so the volume divided by the rate at which it goes in will give the time taken to fill it. If it was just 5, you could see it would be 13, so it's going to be pretty close to that, 12.97 seconds. And we are asked to the nearest second, so yeah, 13 seconds is the answer here to fill up this. Do an experiment with your tap at home. The company decides to change the position of the line in order to limit the capacity to 60. They're saving money. So a third pi r squared h is equal to 60. So pi, well, r squared h is equal to 60 by 3, 180 over pi. So how far vertically below the rim of the cup should the line F be drawn? So we are looking again at similar triangles here, because with the second triangle here, this one, I have my big one, my 3.3 and my 8.37. And in my smaller one now, I don't have any information. I have the radius and the height. But what I can do with similar triangles, I can get the radius in terms of the height, or the height in terms of the radius, which will enable me to simplify this equation. So if we do 3.3 over r is equal to 8.37 over h, we can say, well, what we do here, we'll get r in terms of h. So we get 3.3, we get 3.3h is equal to 8.37 r. So 3.3h over 8.37 is equal to r. So if you fill this back in up here, 3.3h over 8.37 to be squared times h is equal to 180 over pi. Let's use a calculator for 3.3 squared divided by 8.37 squared. That's going to give me 0.15544. That's the 3.3 squared divided by the 8.37 squared. I'm going to have h cubed is equal to 180 over pi. And 180 over pi is actually 1 radian, isn't it? So we have 57. So if I do 180 over pi divided by the 0.15544 rounded, I will get 368.6. 368.6 is equal to h cubed. So that will give me h to be the cube root of that. H is equal to just over 7. 7.1699, 7.1699. Do I need that many decimals? Maybe not. So what are we asked in this question? We're asked how far below. So 8.37, we've gotten this side here from here to here to be minus 7.1699, so I'll say 7.17 there. I'll round that one off to 7.17. It goes in evening. We're only 1 decimal here, so that's going to be 1.2 centimeters below the top.